We are utilizing a multi-dimensional dopaminergic NBAC memory game to improve working memory as a part of the Jahannikia Neurolab at ASDRP. And our current members are Neha, Sharma, Diigant, Srivastava, and Shriya, Nanjanagud. And something we do have IP, intellectual property, in this project. So there's some things that we can't exactly share, as we have some final things that we're working on. So going over the background, just a little bit about this project first. We are creating a dual NBAC task, and we've added gamified elements into it. We will be explaining all of this, but the goal is to help adults improve their working memory through the gamified dual NBAC. So working memory is the cognitive process that helps us retain short-term information by using attention and focus, and it's responsible for us allowing us to temporarily manipulate information that we just received, kind of like remembering a phone number long enough to dial it. And at the center of this process is the prefrontal cortex, and it's kind of like the central executive hub. It doesn't store memory itself, but it helps distribute information to other areas. And all of these pathways pass through the attention controller, which filters and prioritizes what we focus on. And working memory isn't just about remembering things, but deficits in it have been linked to disorders such as ADHD, dyslexia, schizophrenia, anxiety, and more, such as bipolar disorder. So now a little bit about the NBAC task. The NBAC task is a well-studied way of helping people improve their working memory. This is a cognitive performance test that challenges you to remember a stimulus from n steps ago. For example, in a 2-back task, you need to identify when the current letter matches the one shows 2 trials or 2 stimuli earlier. The version we are using is a dual NBAC, which adds a second stimulus to make the task a little bit more complex, such as having audio and a visual cue for you to remember. And functional MRA shows that the NBAC task activates both the frontal and parietal regions. And finally, a little bit about the dopaminergic system. The dopaminergic system is a network in the brain responsible for processing dopamine, and it plays a huge role in motivation and learning and actual attention for the NBAC task. The system is split into 2 main pathways: the mesocortical pathway, which sends dopamine to the prefrontal cortex, and the mesolimbic pathway, which sends dopamine to reward areas. And by engaging the dopaminergic system, especially through rewards in our gamified platform, it can help improve cognitive performance by not exactly helping working memory, but actually giving participants a reason to continue. And our study builds on this concept by creating the gamified version of the dual NBAC. And the goal is to increase both engagement and working memory performance by leveraging the dopamine pathways.
All right, so I'm going to cover the methodology. And so first, we gave everyone a baseline test to assess their initial working memory. Then we divided them into 2 groups. The first group played the game, which was basically the task, but with more engaging features, such as different genres. For example, we had fashion, electronics, cars. More gamified elements we added were a more complex and colorful user interface and an in-game store. The second group played the game. Over here, where it says the NBAC game and NBAC task in right after baseline visuospatial test was where both groups played either the game or task for 70% of the time. And the second group played the task for 70% of the time, which was more boring than the original NBAC, than our original NBAC game, and consisted only of shapes. Then we administered the baseline test once more to assess any changes in their working memory levels. And we also administered a job form survey, and we'll get more into that later. After that, we switched both of the groups for the rest of the 30% of the study. anyone who was playing the game before now was playing the task, and anyone who was playing the task before was now playing the game. Then we administered the baseline test one more time, and we gave them another engagement survey so we can kind of gauge how they liked the game more than the task, or vice versa. So we had a total of 13 participants play for a total of 3 weeks with about 5 consecutive days each week. The groups were split between 7 and 6, and we had 3 rounds with 12 questions of each genre. And that's mostly for the game. But if you were playing the task, it was only the shapes genre for all 3 rounds, which can get pretty boring. We also incorporated a lot of breaks in between so that the players wouldn't get overwhelmed. But moving on to the JobForm questionnaire. So JobForm is basically a HIPAA compliant platform that allows us to safely access PHI or patient health information. And we asked them a lot of questions to do with their personal opinion, such as which game would you rate higher on a scale of 1 to 10, with 1 being the lowest and 10 being the highest. We also asked about their levels of engagement and their self-evaluation, such as would you want to play the game for a longer period of time, or did you find the game challenging? And we found these questions to be pretty important because all participants in our study were adults aged 25 to 60. And we targeted this group specifically because working memory mostly takes place in the prefrontal cortex, which fully develops by age 25. And so moving on, here's our technology. Here are the technologies that we used. So we stored all this information in Firebase, and we used Node.js as our backend, React.js as like our framework for the front end. We rendered everything on white, and we also used Firebase Cloud. And here are some pictures of our game, and I'll kind of explain everything. So on the bottom, we have a picture of our homepage, and we have a play button and a tutorial. We had 3 total platforms in total, so this is the actual game, but for the task and the baseline test, we had separate tutorials. If you were to click on the brain image over here, it would lead you to the brain evolution page. And this was another feature we added because we wanted them to be more engaged. So basically how it works is the more you play, the more coins you earn, which are showcased over here on the top right. And the more coins you earn, the more you can grow your brain. We also had a progress bar to show how many days they played per week. And on the side, you also have a store where they can buy things with the coins they earn through playing the game, such as different backgrounds for the game. They also had a settings page, and they had a help page so they can contact us in case anything went wrong. They had a log out button, and they also, yeah, that's about it actually. And yeah.
And now I will be discussing the studies and results of our experiment. So as Neha was saying, there were 3 baseline tests conducted, one before the study, one after the first 10 days, and then one after the 15, which is the end of the entire experiment. And there were 2 job form surveys that all the participants had to complete. And the data that was analyzed was accuracy, response time, the day number, the session number, and the round number. So the population, we had 13 participants total, 6 in the control and 7 in the experimental. The average age for the control group was 43, while the average age for experimental was about 40. They were all reported that they were comfortable with technology in the demographic form that they all had to fill out prior to us giving them their login information. And so then once all the data was collected, we had to further analyze it. For statistical analysis tests, we did correlation analysis, a DID, a difference in difference, and ANOVA and pairwise t-tests. We also did modeling approaches like causal, mathematical, and LMM, linear mixed modeling, and average accuracy between the TA and TB groups, and reaction time and overall accuracy was also further analyzed. So for our causal modeling, The main reason we used this was to estimate the impact of group assignment and day of the training on accuracy and reaction time. We first modeled the group and day as independent predictors and then assessed the interaction term to identify the causal effects. We mostly focused on the between group differences across time. And we like to focus on causal modeling specifically because it produced our most significant finding from our overall experiment. We saw that on day 11, which was when the experimental and control group switched, we saw a great change in their accuracy for both of them. However, reaction time didn't really change significantly for either group. But the main takeaways that we can bring from causal modeling is that this switch disrupted the accuracy for the experimental group while the control group improved. This shows a more causal relationship between the switch and accuracy. So here are some plots and charts. Here on the left is accuracy for groups TA and TV, the control and experimental, every 5 days. We can see that the control group is higher for the first 5 days, but then the experimental has higher accuracy for the rest. And here we have, on the right, we have the reaction time for the experimental and control every 5 days. The control group has a higher reaction time throughout all 15 days compared to the experimental. And this is just the accuracies by each day for both the control group shown on left and experimental shown on right. And here are some violin plots that show both reaction time and accuracy distributions based on gender. Here on the left, we have reaction time based on gender. On the female participant side, we see less variability, but they have one outlier, which may have been skewing the mean below the median. And we can also see that the reaction time was slower, most noticeably in the first quartile. The shape of their plot is more compact vertically and wider horizontally, which may indicate a consistent reaction time. On the male side, we have a more symmetrical distribution with no outliers, indicating a normal spread. On the plot on the right, on the female side, they had relatively consistent accuracy scores, and the overall shape of their plot was more compact, but however, it was a higher median accuracy, but their outliers lowered their mean slightly below the median, which skewed their results. And on the male side, they had greater variability.
So our future work includes publishing in a journal, and afterwards we are trying to finish the app and publish in both the Apple Store and Google Store, I believe. And currently we're just waiting back from Frontiers in Psychology for some more peer editing. But next slide, please. So if you would like to read our preprint and take a look at our references, please scan this QR code, and I usually put it in the chat as well. This is our team. And we would like to thank ASDRP for giving us this opportunity and Zahar Jahanakia for helping us lead this research in the correct path.